I will be showing to you an example of solving linear programming using Excel. So by the way, I am using WPS Office, so I have my own Excel solver. Okay, so in linear programming, we have here our equation. Now, this method will be, or we will call this method as Simplex method in order to solve linear programming problems. So again, in linear programming, we have these functions, objective functions, which is, for example, z equals 40x plus 88y, and then with the following constraints of 2x plus 8y is less than 60. This is in terms of minutes time in M1, and then 5x plus 2y, which is less than 60, and of course x and y must be greater than or equal to 0. Now, using our Excel, now take note again, this is WPS. I am using WPS Office, so this looks similar to Excel. So we have here rewriting our objective functions. We have 40 and 88. We have here 40 and 88. And then of course this 40 is being multiplied by x, so I separate the variable x here, and then this is y. So in other words, this column is for variable x, and then this column is for variable y. So that is 40x plus 88y. And then our objective function, our objective is to maximize the cost, for example z. And then we have our constraints. We have here 2x plus 8y, so 2 times x plus 8 times y, which is less than or equal to 60. And then for the next constraints, we have here 5x plus 2y. You have here 5x plus 2 times y less than or equal to 60. And then for this non-negativity, x and y, I will no longer write this value of x and y. And then this time we are going to solve the values of x and y. So we have here solution values. So I am writing here equivalent to 0 at this moment, and then the other one 0, because we need to determine the value of x and y. I will highlight this one. Okay, so color yellow. And then of course when we find the value of z, I will write it here as our value of z. So let's say we have here, okay, cost. Okay, we have here maximize cost. I will color this one. I will highlight, I will make use of another color, let's say green. And then at this time we have here equivalent to 0. And then of course this one, I will highlight this one, okay, with another color. Now take note, we have here our constraints, and then 2, 8, and then 60. The other one 5 to 60, 5 to 60. Okay, to solve this one using Excel, we have to write here an equation for this color. Okay, equals, we will be using sum product, okay, sum product, and then open parenthesis, and then we will need, since we want to maximize the cost, so we need to use our objective functions. Okay, and then we will write here comma, then after that we will include this one as our array2 drag. Okay, in other words, this 40 times how many number of x plus 88 times how many numbers of y, and then click in enter. Okay, so it is unknown because this is 0, so that is unknown. And then for this part, so if you look at this one, try to look at this one. If I am going to click this part, okay, these are the involved elements, 40 times 0 plus 88 times 0. So this is still 0 because we're going to determine the value here. Okay, So I will just enter. And then same with this one. Okay, I will just copy this one or drag. Now, if I will drag this one, I will change again the color. Okay, try to look at this. If I'm going to click this one, this is the result. So if you have noticed, uh, this value is supposed to be the equivalent of this one. Okay, and then this C16 must be based on our solution value. That's it. So you need to multiply this 2 by this value plus 8 times this value. Okay, so we click enter. Now, if you want to have this one, again, click this element. Now, if you notice, we have here our first array. We call this one as our first array, color blue. That must be your 5 and 2. And then the second array, it must be 0, 0, this one. So we have to change this one. Okay, and then enter. So again, if we check this one, you have here your arrays. And then if we check this one, double check your arrays. And then for the next one, okay, we have now the correct arrays. Or if you want to, okay, so I've got this one. Okay, enter. Or if you want to, here is another way of writing that. Okay, I will erase this one. I will align this one here. Okay, so that all values of x and y must be aligned with this one. So I will write again equals sum product. So this is another way. And then open parenthesis and then click this element, your first array. And then the second array, we have this one. Okay, and then enter. Now, we go back to this one. If you have noticed here, this is our array. We want this one. We want to copy this formula for the other area. So, we want this value to be fixed. So, we will write here dollar sign, okay, between your letters and number, or before your letter and then before your number. And then this one, you will write dollar sign again, dollar sign, and then the dollar sign 15, and then enter. Okay, and then this time you will just click this one and then drag it here. Okay, so we do not have value here, so we will just erase this part. Okay, so if you have noticed, the value here is 0, so we will check this one. We will see if we need to change. Okay, if you look at this one, we need not to arrange this one. How about this one? So we will check again. This value, the second array, is fixed from this area. Okay, enter. Now, take note, we need to identify. I will change this one with other color. Okay, we need to identify our maximum cost as our objective functions, and we also need to identify the values here. So using your Excel, so Excel, I am using here WPS, so I will just click here Excel solver. In Excel, you will be using Excel solver. So for this one, I will type here solver and then click enter. So it appears here solver. Okay, this is my solver parameters. Now in Excel solver, I think that is Excel solver. In my case, I have here solver parameters, but the content here is the same. Okay, so I will reset here the values. So if you have noticed, these are now empty. Now First, you have your set objectives. This will be your objective function. So this one is our objective function. So we will click this one because we need to find this value. Okay, so if you have noticed here, and then you have here two maximize or minimize or value of. So we will just choose maximize because we are maximizing our cost. So if this is our minimum, then we will click this one. If we make use of maximum, then we will make use of this one. And then on this part is by changing variable cells. Okay, this is our solution values. This will be changed. So we will just click this one. If you want to enter a value here, we will just click this one and then drag here. Okay, and then if you have noticed here, release your mouse. So we have here, and then our subject to the constraints. These are our constraints. These two equation. So we will just input this one. That is why we need our correct formula, sum product, and then we will input this one. Okay, so we will add now cell reference. If you have noticed here, your symbol here is less than or equal to, so they have the same symbol. So all you have to do is to drag this one because they have the same symbol. Okay, if you have noticed here, if in case this is greater than or equal to, then you have to separate. You only have to drag this part. Okay, so that is your cell reference, and then this time constraints. So make sure this is less than or equal to, less than or equal to. You have here an option. Okay, so less than or equal to, and then the constraints we have here 60 and then 60. So you just click this one. Okay. Okay, so we have here, and then make sure you click this one, make unconstrained variables non-negative. And then of course this one, select a solving method. So we will be using simplex linear programming. Simplex linear programming. Okay, and then click this one, solve. Notice this one 0 0 0 0 0. So we will click this solve. Okay, if you have noticed, there is a change here from 0 0. Okay, so click OK. If you want here the values of your answer sensitivity limits, you can have this one highlight, or you can, if you don't want this one, then you can unhighlight this one. So in my case, I will highlight this one. So we have here OK. These are just a report. Okay, so if you have noticed here, the value is 10 and 5. And then we have here our maximum cost, which is 840. So in other words, we need to have this product, 10 products of X and 5 products of Y, so that we have a maximum cost or profit. This is not a maximized cost. Let's say maximize profit. Maximize profit. Okay, so assume we maximize our profit. So you have here 840. So this will be our final answer, 840 as our maximum profit. And then we have here the values of your X and Y to produce, so that we have here a maximum profit of 840. Okay, now another example. We have here our objective function is 0.02 plus 0.04 plus 0.025, and then we are going to minimize the cost, and then subject to the following constraints. So we have here first equation 3 to 4, second equation 2 3 1, third equation 1 0 2, fourth equation 6 8 4, and then we have here another equation wherein we have the values of z less than or equal to 5. So in other words, we have here this equation 3x plus 2y plus 4z that is greater than or equal to 64. And then another equation 2x plus 3y plus z is greater than or equal to 80. And also this one, that is x 0y, so that means x, and then 2y, x plus 2y, that is greater than or equal to 16. and then 6x plus 8y plus 4z is greater than or equal to 128. And then we have here your z times 1, that is z, that is less than or equal to 5. Okay, so we are going to compute the values of our x, y, and z so that we can have a minimum cost of, we do not know, so we need to find. So I have to highlight this one. We need to have this value, and then we also have this one. I will highlight this uh, area because we will input a value to this cell. Okay, okay, so again, this one, sum product equals sum product of your first array. We have this one, your objective function, and then comma, and then the second array we have here, okay, and then close parenthesis. So we need this one to be fixed, so we will write here uh, dollar sign, okay, letter, I mean dollar sign before the letter and then before the number. Okay, we have here your array 2, and then this F13. So before F, I will write here a dollar sign and then 13, another dollar sign so that it will be fixed. So enter. Okay, we have here 0, and then just click this one and then drag. Okay, so if you have noticed, we need to have this value, so we will delete this one, and then no color field. So I will change this one. So it's up to you if you want to have a color like that. So for my case, I will have here 0 0 0 0. Okay, then again solution, this is 0 0 0, or even if you will not write here 0, then it's okay, anyway that is blank. So if you have noticed, there are no values from each color cell. Okay, this time we will apply our Excel solver. So I have here solver, I will enter. So we have here, I have here my Excel solver. So reset all, because we want to start our Excel solver. Okay, now this one, set objectives, this is our objective function, so we will click this one. Okay, and then our target is to minimize the cost, so we will click this min, not max. So minimize, and then by changing the variable cell, of course we will click this one as our solution values. And then our constraints, subject to the following constraints. We have here greater than equal, greater than equal, greater than equal, greater than equal. This one is less than, so we will just copy this one. Okay, so we will click add, and then our cell reference, we will just copy this one. This is from greater than or equal to, and then we will change this one as greater than or equal to. And then our constraints, of course, this one, and then okay, and then add. We need to add because this portion, this constraints, is less than or equal to. So okay, so cell reference, we will click this one, and then click okay, this is less than or equal to, and then the constraints, we have here 5, and then click OK. So if you have noticed, this one make and constraints, and then this one is simplex linear programming, and then solve. Once you click the solve, of course you have this value. So if you have this value, okay, so you have your objective functions, the minimum cost is 0.8, and then you have here the solution values, which is equivalent to 40. So this is now our solution. We need to produce x, 40x, and 0y and z, so that we can minimize with our cost equivalent to 0.8. So that is how we use our uh, Excel solver to solve linear programming. And then this method is what we call as the simplex linear or simplex method or the simplex linear programming.